All right, children. I am a little dead inside as this is the second take. Computer froze up. Didn't it, Mr. Annie?
Sure did.
Mr. Annie's here with us today. Woo-hoo! Yep, we already did this. And I'm going to do the same joke again. Hey, guess what? We are indeed at least 6 feet apart. Mr. Annie, can you take that tape measure? I am. 9 feet. All right. That's what I'm talking about. Safety first. Math second. You remember that. All right, let's go for it. So, we're doing some trig identities today. I love these. It's all a bunch of, it's kind of like proofs in a way, which you know I love proofs because I teach honors geometry, but it's not the same two-column proofs. All right. Quotient identities. We should know these. Tangent is sine over cosine. It's reciprocal cotangent. Flippy floppy, cosine over sine. All right. Reciprocal identities. Cosecant is 1 over sine. Secant is 1 over cosine. And of course, cotangent is 1 over tangent. Lastly, we already covered these, Pythagorean identities. Boom, there we go. You can get any one of those from sine squared plus cosine squared equals 1, which we did in the previous lesson. So make sure you know these, commit them into memory. They should be second nature to you, all right? Because your brain moves a lot faster than your eyes on paper looking at these things. You're going to work very quickly if you know these and can apply them, all right? So we're going to do some basic little strategies here for each one of these, and then we'll get into more complex problems. So the first one says, simplify by rewriting in terms of sine and cosine. That's one of our strategies that we're going to list out. So I'm going to go ahead and do that. If I have cotangent, cotangent is cosine over sine. And I know that cosecant is 1 over, sine. Lovely. Now, I can multiply. If I'm dividing by a fraction, it's the same as multiplying by its reciprocal, right? I've seen Miss Price do this cool loopy thingy with the arrow. That's saying, hey, reciprocal, write it next to it, multiply. And then you are cash money, as a recent YouTube comment said about my 8.3 geometry video. I feel pretty awesome about that. Said it was cash money. I don't even know who that person is. All right. So reciprocal of 1 over sine is sine over 1. Now I can cancel those out, and I'm left with cosine over theta. Cosine of theta over 1, which is just cosine of theta. Look at that. Nice and simplified. Nice and neat. All right. Next one. Show that cosine of theta over 1 plus sine of theta equals 1 minus sine of theta over cosine of theta by multiplying the numerator and denominator by 1 minus sine of theta. 1 minus sine of theta is the conjugate of 1 plus sine of theta. That's why we chose 1 minus sine of theta. It wasn't because of the right-hand side. It's because of what we saw on the left-hand side. All right, so we're only going to work with the left-hand side in this, and that's what you're going to see in these more proof type or verifying identities types of problems. So if I multiply by 1 minus sine of theta in the numerator and the denominator, I would have, I'm going to leave it as cosine of theta times 1 minus sine of theta. I'm going to leave that as is. And then I'm going to have 1 minus sine of theta times 1 plus sine of theta. I'm going to multiply that out, but I'll write it down first. Now, the reason why I'm choosing to multiply that one out is because I see it's a difference of 2 squares that's been factored. So if I multiply that out, we should get something very nice and wonderful. Check it out. Trust me on this one. Trust me. So in my denominator, I'm going to have 1, and then 1 times sine of theta is just sine of theta. Negative sine of theta times 1 is negative sine of theta. Those will cancel each other out, and I'll be left with minus sine squared theta. And holy guacamole here, ladies and gentlemen. 1 minus sine squared theta, that's a rearranged Pythagorean identity. That's cosine squared theta. Woo! So I'm going to have cosine of theta times 1 minus sine of theta over cosine squared theta, right? Sine squared plus cosine squared equals 1. So I subtract the sine squared theta part over, I'm left with cosine squared theta. Bingo, bango. All righty. And now you might see why I didn't multiply that numerator and distribute it in, because I didn't really see any benefit for it at first. So now I can cancel out the cosine of theta with 1 of my cosine squared theta, right? One of those. And now look at that. Look at that. I'm left with 1 minus sine of theta over cosine of theta. And I'm pretty darn tootin' sure that's what we wanted over here. 1 minus sine of theta over cosine of theta. Chickadee check. Done. Awesome sauce. Let's go on to example 3. Oh, man, I've never seen this problem before. Oh, wait, I have, because I already did all these problems, and then my computer froze up. But I'm here to give you the math. Right, Mr. Rainey?
Heck yeah.
Heck yeah, we're here to give you the math. All right. So here it says rewrite it as a single ratio, meaning let's get a common denominator. If you remember back into the days of fractions and adding fractions together, get a common denominator when there's nothing in common, like say it's like a 2 and a 5 in your denominator, you multiply by each other. So I'm going to multiply this one by cosine of u over cosine of u, and this one by sine of u over sine of u. Also thing to point out that I meant to mention earlier, but I forgot to say, because I said it earlier when I recorded this the first time. Cosine of u over cosine of u is just 1. It's a clever form of 1. And multiplying by 1 doesn't change anything, so mathematically this is still equivalent. The same goes for the sine of u over sine of u. We're multiplying by a clever form of 1. Alrighty, let's go. So the first one's going to be cosine of u times 1 plus sine of u plus, and then I'll have sine of u times cotangent of u minus cosine of u, all over my common denominator, cosine of u times sine of u. Now, don't get all crazy on me and think you can just like cancel out, oh, just cancel those and cancel those. Yay! No, you cannot do that. Okay, do not do that. Terrible idea. Also illegal. It'll land you in math jail, not a place you want to be. But what I can do is I can distribute this in. All right, I can distribute that in. So let's do that. And I'm going to show you why I want to do that. Because before we didn't distribute in on one of them, but you're going to see something here in a sec. I'm going to work with this one over here on the right-hand side first. So this is sine of u times, and I'm going to change that cotangent to be cosine of u over sine of u, and then minus sine of u cosine of u. Okay, now what you're going to see here is we're going to get a cancellation of the signs here in this spot. And also we have minus sine u cosine u. Well, think about when I distribute this one in. I'll have cosine u plus sine u cosine u. Those are going to cancel, right? So you have to look ahead a little bit and be like, oh, wait, if I do distribute that, they're going to cancel each other out, and that's all good. So I have cosine of u times sine of u. Now, these will cancel out. Gone, because they're opposite signs, right? That's wonderful. And then I have, let's see here, cosine of u plus, and then this is gone, right? Ooh, let me get that in the same pink marker here. Sound effects necessary. And then I'm left with cosine of u all over. Whoa. Cosine of u times sine of u. So what I have here, normally I'd like to be working down, so I'm going to, I would have, let's see here, 2 cosine of u over cosine of u sine of u. But I'm not done yet. Now my cosines will cancel out. And that's dope. So now I have, we're still not done. I'm just going to work to the right here because otherwise I'm going to get in the way of the next problem. I'd have 2 over sine of u, which is the same as, well, the reciprocal of sine is cosecant, so this is 2 cosecant of u. And there's my final wonderful answer. If you can get rid of a fraction like that, awesome. If it said right in terms of sine and or cosine in its most simplest form, you'd be the step prior. So sometimes the wording of the problem gives you one thing versus the other. You know what I mean? You know what I mean? You know what I mean, Mr. Rainey?
I know what you mean.
He knows what I mean. All righty. Example 4. Oh, this one's fantastic. Simplify by factoring. Okay, so another strategy for us. Again, it's not always going to tell us what to do, but we're just doing the practice. And now we're going to get, after this one, into where you got to figure it out for yourself. You got to put your thinking caps on. All right. Sine squared u minus 1. Well, that's not cosine squared u. You got to be 1 minus sine squared u, right? So why don't I factor this? Because it is a difference of 2 squares. So I'd have sine of u minus 1 and sine of u plus 1 all over. And I got a GCF of a tangent here that I can take out. And then I get sine of u minus 1. Woo! Woo! I can go ahead and I can I can cancel those bad boys out. So now I'm left with sine of u plus 1 over tangent of u. And that's pretty darn dope. Now, you might be looking at that and be like, well, can we do something else? Because tangent of u, that would be sine over cosine. And, I'm gonna do a little sidebar here. If you wanted, you could think of it as dividing by tangent of u is like multiplying by cotangent of u, right? Dividing, multiply by the reciprocal. So sine of u plus 1, and then cotangent is cosine over sine. And if I were to distribute that in, I'd have, cosine of u over sine of u times sine of u would, your sines would cancel, leaving you with cosine of u, plus, and then you'd have cosine over sine, which is cotangent of u. So I would say that would be another acceptable form. It does get rid of the fraction, which is nice. Either one, we'd accept either one here in this case. But just a nice little, hey, sometimes, to each his own, to each his own. I had some delicious tacos today. I'm thirsty. That's some good agua. All right. Establishing your identities. So to establish or prove an identity, you transform one side of the equation so that it looks the same as the other, okay, so that it is the same. You can't perform operations on both sides, and there is a good reason for that. If you perform operations on both the left and the right-hand side to prove something, you have now assumed that they are already equivalent. That's not what we have. We're trying to prove that they are equivalent. So you have to just work with the one side to show that it is equivalent to the right-hand side by manipulating both. You've assumed that you're already good, which you're not, okay? Generally speaking, we work with the left-hand side because it is usually the more complicated one. But in the event that the right-hand side is more complicated than the left, work with the right-hand side. 99% of the time, the left-hand side is going to be the complicated one, all right? So that's step one. We're going to work vertically down as long as we have space, all right? Some of these we might run out of space. Use algebra, good algebra skills, fundamental identities to simplify everything. You want a common denominator with your fractional ones. And then also consider converting into sine and cosines. That is often a go-to for me. I like to try to change it to that. It's a little bit easier to work with. And it looks like, that might be something that we can do here on this very first one. So let's get after it. Let's go for it. And I'll leave these steps here for now. So I'm going to go with that fourth consideration there, which would be right in terms of sine and cosine. So if I do that, I'm going to have 1 divided by sine of theta times, and then tangent is sine of theta over cosine of theta. And look at that. They are going to cancel. And you may have actually seen that it's nice to look ahead a little bit when you're dealing with these. Be like, well, am I going to get some cancellations if I do this, and try to think a couple steps ahead. So now I have 1 over cosine of theta, which I know is secant of theta, which equals secant of theta. Whoop. Check. Done. Awesome. America. We are halfway done here. There are 10 examples. I know you're like, what? 10? That's it? I know. It is a lot. But it's good practice. All righty. Next one here. Establish the identity. So we got a sum in the numerator. We got a sum in the denominator. It's going to equal tangent of u. Okay. So we could maybe think, okay, well, why don't I use the conjugate, right? 1 minus tangent u or 1 minus cotangent u. But which one are we going to do? I don't know. I'm going to go the route of writing in terms of sine and cosine, okay? You can do it. There's sometimes multiple ways you can do these, but I'm going to go the route of sine and cosine here because I'm a genius and I can see the future, and I've already worked the problem. All right, let's go. So I would have 1 plus sine of u over cosine of u over 1 plus cosine of u over sine of u. Now, I'm going to need to get a common denominator here in the numerator, and here's my reasoning why. If I get the whole numerator to be its own fraction and the whole denominator to be its own fraction, I can then multiply by the reciprocal of the denominator and hopefully get some cancellations. That's my long shot here of what I'm thinking. And hey, if it doesn't work out, I can always go back to the drawing board because I've got an eraser here, right? Always do math with pencil. Okay. So I'd have cosine over cosine for the first one, and then sine over sine. Lovely. I'm going to bring this one back way up here. All righty. So now I'm going to put that all into one fraction in the numerator, which would be cosine of u plus sine of u over cosine of u, all over sine of u plus cosine of u over sine of u. Lovely. Now I can go ahead and do the little multiply by the reciprocal. So here's what I'm going to set up. I'm going to have cosine of u plus sine of u over cosine of u times sine of u over sine of u plus cosine of u. Oh, snap. Sine of u plus cosine of u is the same as cosine of u plus sine of u, so that will cancel. That's awesome. And you might already see, I've got sine of u over cosine of u. That's tangent, brother. That's tangent of u. And you are correct. Boom, done. America, freedom, rock and roll. That's what I'm talking about. All right, example 7. Feel free to pause if you ever need to here. I'm trying to get through this thing in a timely manner, and I'm also hoping that this thing doesn't freeze up on me. I shouldn't have said that. Knock on fake wood. Okay. All righty. Whew. This one looks exciting. We're already in terms of sine and cosine, so that's cool. But how about a common denominator? We've got two separate fractions here. So my thought is if I can get it into one fraction, perhaps I can get some cancellations going, some things combined, stuff like that. So I'm going to go the strategy of common denominator. So I need to multiply by, these don't have anything in common, so I'm going to multiply by each other. So this one will get multiplied by sine of theta over sine of theta, right? A clever form of 1. And this one will be 1 plus cosine of theta over 1 plus cosine of theta. All right. So now what I have is I have sine squared theta. That's nice to work with. Plus, and then I have 1 plus cosine of theta times 1 plus cosine of theta. I'll FOIL that one out in a sec here. I don't want to do too much to scare you children all at once here, you know. Scary enough. Okay, so there we go. Parenthesis. So I'm going to FOIL out the 1 plus cosine theta times 1 plus cosine of theta, because that's going to give me a cosine squared theta, isn't it? And if I'm thinking ahead, which is always good to think ahead, if that's paired up, added with sine squared of theta, I can use a Pythagorean identity. So here's what we got. I'm going to have sine squared theta plus 1 plus, then cosine times 1 and cosine times 1 is going to give me 2 cosine of theta plus cosine squared theta. All over, and I'm going to leave this one for now, because although I have distributed before, I currently do not see a benefit to do so, right? I'm looking ahead. I don't see a benefit quite yet. Maybe there will be, maybe there won't be. In the time that it does, then I'll distribute it. But for now, I'm going to leave it. So I have sine squared theta and cosine squared theta. So these can change to 1. I like it. So that means I will have 1 plus 2 cosine theta over sine of theta times 1 plus cosine of theta. And we are once again running out of room. All righty. So now what I have, if I combine any like terms, I'm going to have 2 plus 2 cosine of theta over sine of theta times 1 plus cosine of theta. And I forgot a parenthesis again. My goodness, I'm careless. Okay, so now you're looking, you're like, dude, well, what the heck, man? What can we do here? Hold up. Hold the phone. 2 plus 2 cosine theta. There's a GCF there, but that GCF is not a trig function. It is just the number 2. 1 plus cosine theta is left. Oh, snap. Look at that. We got some cancellations. Hold up. Pink marker. Now I have 2 divided by sine of theta, and you already remember this from one of the previous problems probably. That is 2 cosecant theta which is equal to 2 cosecant theta. We have now proved that that messy left-hand side equals 2 cosecant theta. We are done ski. All righty. Awesome sauce. And just to reiterate, these became 1 by my Pythagorean identity. Some people will then group them together. We were using a lot of space, so I just decided to circle them and show you, okay? But I want to make sure that you realize, hey, sine squared theta plus cosine squared theta is equal to 1. That's where we got that 1 from, in case you were wondering. And if you're like, I was wondering, Mr. Allen, thanks so much for going back. You're welcome. I know, I'm a fantastic person. I just care. I just care so much. All right. I don't know if I've flexed yet, but I've got my Supreme flannel on here as I'm recording this video. It really is, okay? It says on the pocket, but it's very small. That tag says Supreme. I would not lie to you. All right, this next one. Oh boy, example 8. This is where it was last time. Cross your fingers, folks. All righty. Establish the identity. All that's going to equal 1. I got 4 different trig functions going on here. This seems like a nightmare. Now, what I'm going to do is I'm going to try going the sine and cosine route. Okay, terms of sine and cosine, at least it gets me down to 2 trig functions instead of 4. That seems like good news to me. So tangent is sine of v over cosine of v. Cotangent is cosine of v over sine of v. All over. Secant is 1 over cosine of v. And cosecant is 1 over sine of v. Lovely, lovely, awesome sauce. Okay. Again, all that's going to try to equal 1. And you might be thinking like, dude, we've got like 4 fractions now. How is that even helpful? Well, I tell you what. Hang tight. All right. I'm going to get my numerator together. Common denominators. So that means that I'm going to multiply by, and I'll use a little light blue here, cosine of, oops, not cosine. My goodness, Mr. Allen. Sine of v over sine of v. And you may already be seeing, you're like, hey man, that's awesome, because that's going to give me some sine squared, which is always helpful to work with. They're going to have cosine squared. Oh my goodness. Are you seeing a Pythagorean identity in the future? Sorry, spoiler alert. Spoiler alert. Did not mean to ruin it for you, Mr. Annie. I feel terrible. All right.
Still in suspense.
He's still in suspense because he's typing an email and has no idea what's going on. Plus, he probably has no idea what's going on, regardless of typing the email, because trig identities are not part of the social studies curriculum. All right. So I have sine squared v plus cosine squared v over sine of v, cosine of v, all over 1 divided by cosine of v, sine of v. I'm seeing some good stuff here. I'm seeing some real great, awesome, good stuff. So I'm going to have 1 over sine of v, cosine of v. This 1 came from my Pythagorean identity right there, right? Sine squared v plus cosine squared v is equal to 1. Awesome. I'm going to go ahead and also multiply by the reciprocal and do cosine of v times sine of v all over uno. And looky, multiplication, commutative, I can go either order, same thing, cancel. Oh, I gotta go bright pink for the cancellations. I want it to pop. And there we go, ladies and gentlemen. It ends up equaling 1, which equals 1. Check mark, awesome sauce. Dos más examples para you guys. All right, I need to work on my Spanish still. Para ustedes? I don't know. You know what? Help me out with that. All righty. Establish the identity. Oh boy. We're into where I didn't get to record this already once before, which I'm excited about. We're on to example 9. Finally. All right. So for this one, again, I'm going to work with the left-hand side. They both kind of look equally complicated. I'm going to work with the left-hand side. What I'm going to do is I'm going to go the route of multiply by my conjugate. The reason why I'm going to multiply by my conjugate is, think about it. It's a difference of squares. So then I end up getting a sine squared. My middle terms cancel out, so I'm not dealing with any kind of just regular old sine. And that can be very favorable to work with. So I'm going to multiply by 1 plus sine of theta and 1 plus sine of theta. I love when I see squared trig functions because they're easy to manipulate. You have more possibilities, rather. So in my numerator, I'm going to have 1 minus sine squared theta over cosine of theta times 1 plus sine of theta equals, all right. Now, what if I were to replace? What if I were to replace the sine squared theta with, the 1 minus sine squared theta? I can replace that with cosine squared theta, right? Pythagorean identity, 1 minus sine squared theta is cosine squared theta over cosine of theta times 1 plus sine of theta. Now, my cosine will cancel with one of my cosines in the numerator, leaving me with cosine of theta over 1 plus sine of theta, which is exactly what I wanted. Cosine of theta over 1 plus sine of theta. And I've almost forgot. Mr. Andy just left. Check. Done. Awesome. No mess. This feels wonderful. Hopefully the volume has been okay and you could hear me enunciating. If not, it's a total loss. Sorry. All right, last one. Hydrate. Let's get her done. All righty. So, I've got 1 minus and then sine squared theta over 1 plus cosine theta equals cosine theta. Work with the left-hand side. How about sine squared theta? That I could get into terms of cosine, and since my final answer is just cosine, I'm thinking in the future that would be beneficial, yes? So I would have 1 minus, and then 1 minus, let's see here, cosine squared theta over 1 plus cosine theta. Okay, well, I can't do any kind of cancellations yet, but that's a difference of squares. I can factor that. So 1 minus, and then in my numerator, it'd be 1 minus cosine of theta and 1 plus cosine of theta. Don't forget that argument. Don't forget that. I almost did. I'd gotten yelled at. Thrown in a math prison for that. All right, look at that. Look at that. Hold up. Pink marker. Got to have a pop. Nice. So I factored after I subbed in 1 minus cosine squared theta, and now I have 1 minus 1. Don't forget to distribute. That's going to be positive cosine of theta, right? If I distribute this negative to both of those, equals, and then 1 minus 1 is 0, so I'd get cosine of theta is equal to cosine of theta. Boom, check, done. America, freedom, rock and roll, Costco, Riverdog Jenny on the gram. Shout out Milwaukee on that one for the assist on social distancing measures. And you guys have a fantastic day. Thank you for tuning in. I hope you enjoyed the second take of this video. I'll pour my heart and soul into it for you guys. See ya.